Okay, now we'll cover cross product. So the cross product is an operation on two vectors in three-dimensional space. What it does is it gives you a third vector which is at right angles to the other two. Okay, and we call this right angleness orthogonal. Okay, so it takes two vectors, for example, A and B. The cross product gives you this third vector, A cross B, and this is at right angles to both A and B. Okay, it's orthogonal to both A and B. Now here's what the calculation looks like. Now I understand that it looks pretty complicated and easy to get lost in, but we'll get used to it, and then we'll see that it's actually a part of this bigger, more natural calculation called the determinant. But first what we'll do is check that this vector is indeed orthogonal to each of these. How might we do that? Yeah, we could use the dot product. So if I take 1, 3, 2 and I dot it with this third vector, the one on the right here, I would get minus 13, so that's 1 times negative 13, plus 3 times 13, then plus 2 times negative 13, so that's negative 26. Add that all together, I get 0. You can do the same thing with 4 minus 1 minus 5. I dot it with negative 13, 13, negative 13. What I get is 4 times negative 13, that's negative 52. Then negative 1, oops, sorry, that should be a plus. Plus negative 1 times 13, that's negative 13. And then negative 5 times negative 13 is plus 65. Add those together, I get 0. So sure enough, when I crossed these two vectors, I get this third vector, which is orthogonal to the first two. Okay, now let's do a practice problem, and I'm going to do it slightly different to start getting at the underlying determinant calculation. Okay, now to do that, I'll do this first example problem, and I'll go to GeoGebra. Okay, so this is GeoGebra. I like using this because it has a nice 3D graphing calculator. Okay, so I can just type in the points here, 1, 0, negative 1. Just simply type it in, 1, 0, negative 1. Gives me that point A. And 0, 1, negative 1. Put that in. 0, 1, negative 1. Put that in. That gave me the point B. You can see them sitting around there. And what I'll do is just go to Tools, or make a vector, just to make these, well, look like vectors. Create a vector here and another one from the origin to that point B. And here are the two vectors that I started with. Okay, let me just clear that up a bit. There they are, floating around in space. Okay, so I want to find their cross product, and it should create a third vector which is at right angles to those two. So let's do that. And the way I'll do it is write these two kind of on top of each other. So I'll write the vector A here as 1, 0, minus 1. And vector B I'll write below it. Now, why I do that is because it makes the computation of the cross product kind of visually simple. Okay, so I'm going to find their cross product, and I'll do that by ignoring this first column, then taking the product of 0 and negative 1 and subtracting the product of negative 1 and 1. So it's kind of like I do a cross between these four numbers here. Okay, so let's try that. So I go 0 times negative 1, then I subtract minus 1 times 1, That's the first component of this vector. Now the second one comes from ignoring the middle column and doing that kind of cross multiplication looking thing with those other four elements. So I'll go 1 times -1, and then I'll subtract -1 times 0. Okay. Now this middle entry in the vector is a little different than the first entry because I have to introduce a negative here. Okay? Roll with it. We'll learn why that is in a little while. Okay, now to find the third component of this vector, I ignore that final column and I take the product of these and subtract the product of these. Okay, so I go 1 times 1 minus 0 times 0. Great. So I'm done for now. Let's write out what we have. Got 0 times that minus 1, so 1, comma, I've got -1 minus 0 with a negative out front, so that gives me +1. And then the third component is 1 times 1 minus 0 gives me 1. Okay, so that's it for our calculation. Let's put that vector in here. It's just 1, 1, 1. There, it's that point D. Again, I'll turn it into a vector, joining the origin to D. Okay. Now, let's just look around. Sure enough, that third vector D, you can kind of see it as you rotate this object, it's at a right angle to both A and B. That's what the cross product gives us. It's that third vector that is orthogonal to the other two. Great. Okay, so there's a couple properties of cross product. We won't really spend too much time with it. One in particular is that the cross product kind of looks like the dot product in that we can calculate the angle between two vectors in three-dimensional space by doing this, right? I could rearrange that and then it kind of looks very, very similar to the dot product. Okay, so the sine of the angle, not the cosine like in the dot product case, but the sine of the angle between two vectors is just the length of their cross product divided by the product of their lengths. Okay, right? The dot product had the cosine of the angle is equal to the dot product of u and v divided by the lengths of u and v. So it kind of has that similar form. Okay, and then there's some properties here of the cross product. You can read through them. The key one here, the very important one, the whole point of studying this is that the cross product of two vectors, when you dot it with either of the vectors, you get 0, which is another way of saying that the cross product is orthogonal to both u and v. Okay? Another interesting one that comes up in physics all the time, and you've probably seen this in the right-hand rule, when you have two vectors, okay? When you cross one with the other, so if I cross this one with this one with this one, the third vector is given by my thumb, okay? So if I change the order at which I cross these two, so instead of going from my index to my middle finger, I go from my middle to my index, the vector points down, which is hard to do with your thumb. So it would kind of flip the picture, and that's what that first one is saying here. If I take the cross product of u and v, if I reverse the order, if I go the cross product of v and u, I just have to introduce a negative sign, because that's going to flip the vector, the resulting vector. Okay, that's it for cross product. Try it on your own, and we can discuss your progress.